What is reorder point and reorder point formula? The reorder point, also known as ROP, is the inventory level at which an order is triggered to replenish the inventory stock. Read more from this article. Inventory management is a complex task. There are thousands of SKUs to manage every day, and you need to ensure the availability of all of them. You also need to deliver a high service level, keeping low operational cost, and avoid stock shortages. The lack of just one item in your factory may represent a huge lost profit per line stoppage. Your administration staff may take time to calculate the right quantities to avoid such shortage. This process can be automated by introducing the reorder point methodology. Let's see the concept of the reorder point, know the related formula, and the advantages of introducing this methodology. The reorder point, also known as ROP, is the inventory level at which an order is triggered to replenish the inventory stock. Inventories are consumed over time, so that upon reaching the ROP, the item is reordered. Each article, or SKU, has its own reorder point. Essentially, the reorder point lets you place an order at the right time, before the stock reaches the replenishment limit. The order point ROP model requires data input. By using an algorithm, the system will be able to provide the ROP. These are the input data: the rate of consumption of the item, the lead time the item takes to arrive at your factory, the level of your safety stock. It is important to consider that the model is dynamic. That means all variables and parameters suffer changes throughout time. It is recommended to review it and update it every 3 to 6 months. Let's see an example. If the consumption of a given bearing was 10 units per month last quarter, it does not mean it will always be like that. You may have introduced preventative maintenance at your factory. By introducing a lubricating schedule, you reduced significantly that consumption rate. On the other side, you may duplicate your machinery, and your consumption rate is higher now. Keep in mind that the more historical data you have, the lower the data variability, i.e. the consumption rate, the greater the model accuracy. Use this model along with additional data such as quality or brand changes, changes of suppliers or manufacturers, changes in your bill of materials, growth or decrease in your business, teamwork, common sense. The order point, ROP, automatically activates the stock requirements. The ROP model is a useful decision-making tool and helps you optimize your inventory list and save administrative time. This fact allows you to focus on adding value to your organization while letting the system run automatically. Some of the advantages of using this system are: ensure a higher service level, either with external or internal customers. Avoid delays or bottlenecks throughout the supply chain. Avoid getting the items too early. Reduce inventory cost. Optimize your inventory space. Staff save time and focus on value-added activities. Replace your feelings with facts and data. The reorder point, ROP, needs to be calculated per item. Spreadsheets or ERP systems can help you to calculate them automatically. The ROP formula is ROP equals average consumption during lead time plus safety stock. ROP equals LT times AD plus SS, where LT is average lead time, AD average demand, SS safety stock. The reorder point formula is based on a mathematical model, and therefore there are some assumptions as described below. Demand rate is constant. Lead time is constant. Purchasing orders are released per batch. The purchasing orders are released when reaching the ROP. Replacement occurs all at once. Find below a graph summarizing the concepts. As you will see from the graph, The LT, lead time, is the period of time in which the order must be released to avoid falling under the SS, safety stock. Lead time is measured from when the order is placed, T, until when the order arrives at your factory, arrival. The lot size is the volume in units per order released. The lot size can also be optimized by introducing the economic order quantity model, EOQ. As you probably know, the safety stock, SS, is the stock that covers fluctuations in demand. If for any reason your supplier delays the delivery of an item or the consumption rate increases, the safety stock will cover the shortage of items. The next time you release a purchase order, you will cover the consumed safety stock plus the lot size. Let's clarify with another example. Your organization uses on average 100 units of raw material per day, and you keep 1,000 units as a safety stock. Suppose that the orders take on an average of 3 days to arrive. The reorder point is as follows. Average consumption during lead time equals 100 units per day, times 3 days equals 300 units. ROP equals 300 units plus 1,000 units. ROP equals 1,300 units. Note that the lot size is not 1,300 units, but the point at which replenishment is triggered. It means that you need to set the ROP in 1,300 units on your replenishment system for this item and supplier. If you change the supplier, it will also change the delivery time. Be sure to consider this fact on your system. If the consumption rate increases, the next ROP will be sooner. Instead, if the consumption rate decreases, the next ROP will come later. Let's assume now that during delivery time of the previous example, the consumption rate increased to 500 units. That was more than the expected 300 units. Thus, you will use 200 units of your safety stock. Alternatively, if the lead time and/or the consumption rate fluctuate too much, or you don't have safety stock, you can use the maximum figures. ROP equals maximum lead time times maximum demand. Finally, always keep in mind to use the same units. If you express the demand in units per day, then use the lead time in days. If you express the demand in units per month, the lead time will be in months, and so on.